As left our notes, we were discussing average rate of change, also known on the street as slope, as the rise over the run, right? That's the difference in the y values or the difference in the x values. Why do I misspell the word rise?
Because it's y up there.
Yeah, because pre-calc kids mix it up and put the x's on top. How? At this stage of the game, do we do that? I'm not sure. You guys are better than this. Okay? Changing the y's over the change in the x's. Hopefully we know how to find that, and that's not an issue. Okay, now, I need to make this win. We're going to be discussing the connection between different variables. And this particular part of the lesson is talking about a linear relationship between variables. Some of the things that you do and have done in your math class career will not pertain to what you do in the rest of your life. Some of them will. Data collection happens all the time. Many jobs out there analyze data. And they look for patterns. If you can find a predictable pattern. There are people that are constantly studying the stock market to see if they can find a predictable pattern. Because if they can find a predictable pattern, what happens? They make a lot of money. But those patterns keep changing, so they can't quite figure them all out. And they keep saying things, oh yeah, we can teach you how to do this and make tons of money. Yeah, but why does everybody keep saying that, and they have their pattern, they figured out this formula. They can't all figure that out. Because a lot of that stuff happens some of it happens randomly. Anyway, we're going to study some things that have linear relationships. And we could talk about the strengths of those relationships. Out of these choices up here, which one of these 5 choices, A, B, C, D, or E, sorry, it's probably hard to see all the choices there, are the closest to a linear function? A, B, C, D, or E, which ones of them are the closest to a linear function? A's a good one. A's closest to a linear function, sure. And D, closest to a linear function. If you had to put a line through those data, like, oh man, I did a bad job. Which probably means I need to get a little bit closer. That could be the line of best fit. It might be a little bit off, but that's close. Would you say that line has a positive slope or a negative slope? Positive slope. I mean, the same thing can be said over here, right? That's got a positive slope to it. Although you can tell that the points are not as close. They're farther away from the line. Okay? This one, not bad. Alright, definitely has what kind of slope? Negative slope. Same thing for this one. Now what's interesting is when I've said this before, I said, okay, make sure you draw a line through the center of the data. I would get kids that are like this. They'd be like, hey, you went through the center. And I'm like, are you kidding me? All right? We don't want any. We already bought at the office. Kids always suck. Yeah, you should Alright, so I had to rephrase what I was saying. It goes through the center of the data and follows the pattern of the data. So we could get away from those people who like to draw these lines that aren't really the right lines. Out of those 5 pictures, which one doesn't look like a line at all? Ah, letter C. Okay, not a line. Kind of looks like a shotgun went off, you know? Just everywhere. Alright, nothing. Yeah, everything, a game of marbles, right? All random, no pattern to follow. We use words like strong if we think it's close to a linear function. We use words like weak if it's kind of a linear function. And then obviously the one in the red is no correlation at all. No linear correlation, I should say. I don't really see a whole pattern there anyway, so I would probably say no correlation to anything. We can measure the strength of correlation. We can measure the strength of correlation. So, this is a pirate's favorite statistical measure. R, yes. Okay? It's called the correlation coefficient. Correlation coefficient. There's a nasty, ugly formula for this, which you are not going to have to know at all. I'm not even going to show it to you. All right? It's that ugly. You can look it up in a book or online if you would like. No. No, but it involves averages and standard deviations for both x's and y's, and it is a sum. This formula is programmed into all of your graphing calculators. Yes. Yeah, I'll Google that. Okay. The correlation coefficient is already in your graphing calculator, and so when we go to find the line of best fit, or the linear regression line, we will find the correlation coefficient. The correlation coefficient has a high value of positive 1. That is the highest R value you can get. The lowest R value that you can get is negative 1. Okay. You and your neighbors are going to draw a scatter plot. Okay, you're going to make up your own scatter plot of something that has an R value of 1. Now, folks, keep in mind, if it has an R value of 1, it is perfect. After you do that, you're going to draw one that has a negative 1, and folks, it is also perfect. Okay, go. Draw a picture scatter plot that you think has a correlation coefficient of exactly 1, and maybe a different one, and then a second one that has a correlation coefficient of negative 1. No Googling it. If that's what you're doing over there, I see you. All right. Now, if you look at my picture, some of you actually drew a line that looked like it had a slope of 1. I purposely didn't draw one that looked like it had a positive 1 slope, although that would work. What is the key thing here? It has to have 2 things. Positive slope, and every point has to be on a line. Now, I bet you can look at mine and tell me that it's not a perfect 1. Look, right about in here, I'm starting to see, I see some that look like they're below. I'm not really convinced that this one might be above. Maybe the one I just drew was a 0.99. But it's not a perfect one. It's really kind of hard to draw one of those. Okay? So when you went to draw your negative one, even mine's not a negative one. It's pretty close. But that's the idea. It has a negative slope, and the lines or the dots should be on the exact same line perfectly. Now, this might sound a little odd, but you know, it's par for the course with me. What made Superman strong? Here on the planet Earth, what made Superman strong? The yellow sun. The yellow sun gave him his power, which is why in Superman 2, which most of you haven't seen because it's a really old movie, right? The three criminals came from his home planet. They had the same powers he did. Now it's 3-on-1. Bad deal. Okay? So, what made Superman weak? Kryptonite, right? A little piece of his home planet. So, I need you to understand that 1 and -1 are the yellow sun. Strength comes from the yellow sun. 1 and -1. Don't look at me and go, oh, -1, that's bad. Oh, no, -1, that's great. So it's +1. Yellow sun. And as we get closer and closer to 0, what's happening to the correlation? It's getting weaker and weaker and weaker until we get to 0 in the middle, which we call kryptonite. Yellow sun, strength. Right? Out here at the edges, we have perfect correlation. And as it gets closer, now you're going to ask me questions like, well, what do you call strong? Is 0.9 considered strong? Yeah, I would probably consider that strong. Where is the line where you start to cross over into what you think is weak? I mean, what is this, an English class? Right, where suddenly we're interpreting what the poet was saying? You're right, and you're right, and you're right, but not you. Yes, it gets a little vague. I do understand that. Okay? If you start looking at some pictures, even if you go Google, different correlations and start looking at some scatter plots of, 0.25, and you're going to see that there's a, if you're in the 0.7, you're 0.7 on down, that's starting to get weak. It's not really convincing. You got to be in the 0.8s, the 0.9s, or the -0.8, -0.9 before it's really good. So, yes, there's some vagueness to the whole. What do you call weak and what do you call strong? We'll try to err on the really close to the extremes for that. All right, now that blue box basically says everything that we just said. Okay, I need you to get this data entered in your calculator in list 1 and list 2. For those of you who don't remember how to do that, you hit the stat button and the enter button. Now, if you want to clear out a list because you got a bunch of junk in it, you will go all the way to the very top. Let's say we're doing it at L1. You would make sure your cursor is highlighting L1. You would hit clear and the down arrow, and you will eliminate the entire list. And not eliminate, because some kids will actually hit the delete key and lose the list, and then I have to help them get it back. But you go ahead and enter your data in list 1 and list 2 of that calculator. Please do double check your data entry, because that would be the only thing that would screw us up here, is you not getting numbers plugged in correctly. Make sure you have the same number of X's as you do Y's, because if you don't, then it's going to give you an error message when we go further. a chance to get them entered in. Are we all there? Okay. Probably need to get my cameras. Yeah, since I unplugged it. Turn back, switch back to on. Come on. Yes, sir. Come on, don't be so blinding. Alright, that's better. Okay, so you got your information entered in list 1 and list 2. Right above the y equals, it says stat plot. Okay, now I understand that it's creating a scatter plot, but they did not want to abbreviate it scat plot because that's a completely different thing. Let you figure that one out. Alright, so when you get to this screen, which is right above the y equals, everybody there? So second and then y equals, that gets you to this screen right here. Okay, then hit the enter button. Make sure you switch it to on. You want that stat plot to be turned to this switched on. And we have list 1 and list 2. The first one obviously is the type of graph, and you want the one that's got the dots on it so that it's creating a scatter plot. You do not want the one next to it which actually connects the dots. Okay? I mean, that's going to come in handy at different times, but not this time. So, I want my x's in list 1, my y's in list 2. I'm going to use a square for my dots so it's easier to see them on screen. And I can choose whatever color I want. I know if you're using the old style calculator, you don't have that choice. And here in a minute, I might grab one of the old style calculators just to kind of show you the difference when we get to, when we get to the linear regression stuff. If I want to create a window for this particular scatter plot so that it creates the nice x's and y's for me, I hit zoom, and I'm looking for the 9th one in the list, zoom stat. This will cause the window that you need. All of us should have a picture. Well, I'll get rid of the equation that runs through there, so we should all have a picture that looks something like this. Would you call that an R value of -1 exactly? No. Would you call it strong negative? Yeah, strong negative. We should all be in agreement there. Looks close to a line with a negative slope, but not exactly. Okay. So we would like to find the line that goes between them. We're going to do stat calc. So I should be looking at a screen like this if I hit the stat button and then arrow to the right to go to the calc section. And I'm looking for the 4th one in the list, linreg. Okay, now, on the new style, it's going to give you a menu. On the old style, it's not going to give me a menu. Anybody with an old style calculator want me to put theirs up on the big screen? Here, I'll put yours in the video. That way we can look at it together. So if I do, stat calc linreg, okay. Maybe I should clear that out and do a stat calc. 4th one, linreg. old style calculator is expecting you to tell it where the x's and y's are, and so it's expecting you to type something like, it's expecting something like list 1, comma, list 2, comma, and then I'm going to show you how to do y1. So these are my x's, these are my y's, and then this is a storage location. Now the reason I'm going to use that storage location is so that it will graph it for me, and so that I don't have to type in this nasty long value. So on my calculator, if you take a look at the calculators, you'll see that they all have a number pad 1, 2, 3, 4, 5, 6. Right above the number pad you see L1, L2, L3, L4, L5, L6. That's true for the new style calculator and the old. So I'm going to type L1, comma. Now the comma is right above the 7 for those of you wondering. L2, comma. And then for the old style calculator, it's a touch more complicated to get to that storage location, so it's a lot easier on the new style, and I'll show you how to do that. For you on the new style, you have to come down here to store regression equation. That's where you want to be. But on the old style calculator, you have to hit the vars button. That is right below the number, or the 4 arrow pad, vars. Okay. Stands for variables. Okay. Battery is running low and it's plugged in. That's so I'm gonna guess my cord is break inside. Which is possible. Oh, something must work. It's charging now. Okay, so we hit the variables button. Now at the top we want y variables, so we move over to the right. It's already highlighted on function, and so I'm going to hit the enter button and I get a list of choices. Y1, Y2, Y3, we're going to choose Y1. So now that appears on screen. For you with the new style calculator, I got something better for you. On your calculator, you want to hit alpha trace. Okay, that's the F4 that you see there in green. It brings up that same menu for me, and I can then just go here, since it's already selected, and choose Y1. So it's a little bit faster on the newer style calculators. And you will hit calculate or enter. Did you get the correlation coefficient? You probably didn't, and I'll tell you why. Every time you get a calculator or the batteries get changed in the calculator, it goes back to the default settings. So you and I are going to have to do this one time. And unless you change your batteries or something like that, then we might have to do it again. But we have to go into the catalog and we have to turn on something called the diagnostic feature. So right above the 0, it says catalog. Right above the 0, it says catalog. So you'll go into the catalog, whether you have the new style or the old style. Yeah, you'll see some differences in the new style. And we want to go down to the D's. Now you'll notice in the upper right corner, whether you're talking about the new or the old, that the alpha lock button is on. That means every letter is now active on the screen or on the buttons. And so I want to press the D, which is on the far left side of the calculator. It's got X to the -1 on it. And it jumps down to the D section. And then I'm going to continue arrowing down until I get to where it says diagnostic on. diagnostic on. Obviously, I have to push it a few more times on the newer style, but we want to hit the enter button twice so that it says done. Diagnostic on, done. Okay, so make sure you get that selected. Diagnostic on. Now, for those of you with the newer style calculator, you can arrow up. Some of you didn't know that, but you can actually arrow up to previous calculator instructions and hit the enter button, and it will repeat that instruction. Hit it one more time, and it'll repeat it, but now you'll get the correlation coefficient. Now, on the older style calculators, you don't have that up arrow feature. What you have is above, or actually all I'm going to do is second enter. Here, let me see if I can push it up so that you can see it a little bit better on our screen here. Second enter. Every time I do second enter, it goes back to a previous calculator instruction. So that's kind of the old style way of going backwards, so you didn't have to re-enter it. If you want to practice just for kicks and giggles, you can. Or you can do that, you can go backwards, second enter, until you get here, and then you can redo it. I don't know what that was about. Sounds fun. Negative 0.98. Does that confirm that we knew that we were right on the strong negative? Yeah. It's close to -1. -1's perfect. So, now, what did we just find out here? Here you go, sir. Calculator space. We just got y equals -15,000. 358. Let's just say 0.93x plus 73,622.5. We call this the line of regression. That would be kind of a fancy term. So I guess it depends on what kind of party you're at. Or the line of best fits. Sometimes referred to on the street as the love. Sorry, that's just my abbreviation for it. The love. Nope. Okay. What's the slope? What does this slope mean? I need you to interpret the slope. What is this? Okay, I know it's the slope, folks, but you need to interpret it. Look at the situation. List 1 was the price per box, and list 2 were the number of boxes sold. Now, if you want me to, I'll do it this way. -15,358.93 over 1. If you would like me to write it as a fraction, I will. Does that help you interpret? What's the number on the top representing? Boxes sold. And what's the number on the bottom? It's the price, right? It's the money. So specifically price. So interpret what it says. As the price of the box goes up by $1, not sell 15,358.93 boxes. Each dollar we raise this thing really reduces our sales. So you need to be able to interpret what the slope is. Every time the bottom's going up, what's happening to the top value? Is it going up or down? Obviously, if it's positive slope, then it's going up. If you go to the gas station right now, you might pay around $2.50 a gallon. If I ask you to compare the price of, or the number of gallons of gas that you get compared to the total cost, you could find a linear relationship between those two. What would be the slope? If I buy 10 gallons, it costs me $25 if it's $2.50. What's the slope? Yeah. $2.50. In other words, they put the slope right on the sign. Because if I don't buy any gas, they can't charge me a dime. Just like Jimmy John's, the smells are free. You don't see that advertisement on the outside of the building? Okay, plus I know some of you like the smell of gas. Oh. Okay, so we talked about, we wrote the linear model, right? We got that part, write the linear model. Got that up here. Describe the strength, right? We said that was strong negative. In fact, we found out that the R value was negative 0.98, which that's pretty good. We know the direction because we talked about that, strength and direction. Use the model to predict the weekly cereal sales if the prices dropped to $2 or raised to $4. Okay. You've already got this equation in Y1 in your calculator. Now, earlier today, somebody made the suggestion, why don't we go to the graph, which the graph should now have a line on it, right? Because you stored the equation in Y1. Somebody made the suggestion, well, why can't we just hit the trace button and then type in 2 and type in 4? And I tried that. Now, when you hit the trace button at first, you see in the upper left that it's on plot 1. It's on the dots. That's not what I want. I want to be on the line. Well, you can use the up or the down arrow, and you can switch, and now it is actually on the line. But what I found out was that when it's trying to graph the plot, we tried to do this earlier. We typed a 2, and it didn't like it. When you have a scatter plot turned on, it doesn't really like that. So that didn't work. However, we have done this before. We have done this where we go to table setup and we make the independent variable ask and the dependent variable auto. And then we can go type those numbers in, can't we? Type in 2. Looks like we get close to 42,905. Type of 4. We're down to 12,186. Okay, so what's the question? Okay, it's right above your table, right above the graph. So once you set it up, you can put your table in. Okay, if you got a bunch of stuff in XCAP column, you can actually just hit Okay. Any questions about finding those values using the table and the ask feature? Yep. Right, so do you have the table set up and ask for the independent, but auto for the dependent?
Just a quick reminder to those students that have detention.
Okay, this, we'll get to this part later. Maybe I should do some blank spot here. I'll just do it up here in the corner. You can, alright, suppose that you were told that r squared equals 0.64. And you were told that the LUBF, the line of best fit, was y equals 6 minus 3x. Find the value of r. Find the value of r. Now, what would you do with that? If I gave you r squared and I told you the line of best fit, how would you find r, the correlation coefficient? See, most people are going to take the square root of this little equation right here, right? And the most popular wrong answer is this one. R equals 0.8. Can you tell me why that's a wrong answer? Because the slope's negative. The sign of the slope and the sign of the correlation coefficient have to match. So when you saw that the line of best fit had a negative slope, you should have added it to the correlation coefficient. It's not just enough that you take the square root of that 0.64. You do have to pay attention to the slope, because the signs have to match. No. Are you thinking because every time you square something, something gets bigger? If you take 0.8, thank you very much. You take 0.8 times 0.8, you get 0.64. If you had 0.08 and 0.08, then you'd end up with 0.006.